What's up everybody and welcome to the Engine Gremlin channel. This week we're going to be showing you part 2 of how to build the ultimate Ford Straight 6. As always, we want to give a very special thank you to our sponsors who have helped us with this build. We're going to be talking about those sponsors a little later in today's episode. And we want to give a very special thank you to you all for watching this episode. We're going to pick right back up where we left off with part 1 and switch from building up the bottom end of the block to building up the top end. And at the end of the episode, we're going to be showing you the final product. So it's going to be very exciting, and we're going to go ahead and get right into it and get started, so stick around. So we finally reached the portion of the video where we're going to be showing you how to install the head on your motor. But before we get to that, I actually wanted to highlight some of the differences between the original cast iron log head that came with the motor versus the cast aluminum vintage inlines head that we're using for this build. Now, right out of the gate, the obvious difference is in materials. The original log head is cast iron. It's going to be heavy and it's going to hold on to heat. Versus the cast aluminum head, which is going to be a lot lighter and it's going to be a lot better at heat transfer, keeping your motor cool. So one of the other things you may notice right out of the gate is going to be the intake manifold. So as you can see on the cast aluminum head here, that you have an option of changing out whatever your intake manifold is. So this is the vintage inlines intake manifold that they sell, but you could also throw on an Edelbrock on there or a custom manufactured piece, whatever you want to do. You have options. Versus over here, one of the most fatal flaws in this log head design is the integrated cast-in intake manifold. So one of the things you may notice is that because it is cast, you're going to keep that cast finish on the inside. So you don't have the option to port and polish the runners, which in reality isn't really that big of a deal. What is a bigger deal though is the fact that these runners and this intake manifold as a whole actually is incredibly undersized for this size of motor. Even though it's just 200 cubic inches, it's still undersized. And since an engine is a glorified air pump, anytime that you're restricting the amount of air that you can move through that motor, that's bad.
It's bad. Okay.
The other thing you're going to notice is that these runners are really, really short, and they're these sharp 90 degrees, which is really hard for air to make that turn and flow through. And as a result, airflow through cylinders 1 and 6 really, really suffered. And sometimes you can see damage on cylinders 1 and 6 if that problem has gone left unchecked over time. Fortunately, that wasn't something that we experienced on this particular motor. The other thing you may have noticed with the intake manifold is that over here, it's just a little single barrel location for your carburetor. In this case, it was the Autolite 1100 that came with these motors, which it's fine. You know, I don't really like carburetors to begin with, but as far as carburetors go, it's fine. You know, versus over here though, with like the vintage inlines one, you can go to a 4-barrel, you can convert it to a 2-barrel, you can go to a 1-barrel if you want to run like a Holley Sniper 1100 throttle body fuel injection system on there. You can do that. You have options. Over here, you don't really have options, so that's unfortunate. One of the things that was not addressed in the vintage inlines cast aluminum head was the fact that it's not a cross-flow head. You have your exhaust directly beneath your intake manifold. Now, because we're running aluminum here and heat transfer works a little bit better, and we also have better headers that don't hang on to as much heat, it's not quite such a big issue, especially since we're doing sequential port fuel injection. But over on this side, that actually became a problem because you basically had this heavy cast iron header that was soaking up all that heat and then releasing it directly into the intake manifold, again, soaking up all that heat because it is cast iron, and eventually if you were in stop and go kind of traffic, you'd run into vapor lock. Speaking of the exhaust, you know, the other side of the equation when you're talking about an air pump, you have the intake and then you have the outtake. So in this case, the header is the exhaust. And so you don't want to be restricting airflow. Now, in order to do that, we've got a dual 3-to-1 stainless steel header here. It's got plenty of room to remove all that exhaust without restricting the airflow. However, on the log head side, we had this guy. So this is the original cast iron exhaust manifold. And right away you can see there are some either poor design choices or some flaws here. First one being is that these exhaust ports here immediately deadhead. They have to make an immediate 90-degree turn. I mean, there is no run-up room whatsoever. And anytime you have airflow making a hard turn and in an undersized cavity, it's going to restrict airflow. And again, glorified air pump, that's bad.
It's bad. Okay.
The other thing you may notice is right here for cylinders 3 and 4, there's this weird Siamese conversion cavity. Now, granted, there were some aftermarket parts that you could weld into your head to kind of keep them separate, but the jury is honestly still kind of out about whether or not that added any benefit or did anything. It was just a really, really weird design choice to combine those two exhaust ports in this head. Now, granted, these were not bad motors. I know I've pointed out a lot of flaws and I've called a lot of them fatal, which they kind of are. These were not bad motors. They were very reliable. I mean, this one had 163,000 miles on it with no issues when it drove into the barn and then sat there for 35 years. But they also had a lot of room for improvement, and that's what we've tried to capitalize here on this build. So that's the main reasons. Those are the main reasons why we've gone from this log head over to this vintage inline style head. Now, if you want to address a crossflow issue, you can do that, but you will need to import an Australian crossflow 250 head, and that can be pretty expensive. Other than that, the sizing of the valves is about the same. The springs are about the same. Most of that really didn't need adjusting. Even if you stick with the old log head, there are still a lot of modifications that you can do. You can cut off of this single barrel carburetor port and you can weld on a double barrel. You can go to a Holley Sniper throttle body injection like the 1100 that they sell that is made for these motors to get a lot more consistent performance out of these. In fact, if you want to see one of those installed, go check out Ellie's Garage on YouTube for her Falcon build. That was actually a lot of inspiration for this build. So go and check her out. She's very, very, very cool and very fun to watch. The other thing that you can do is if you really want to get out there, you can cut off the entire intake manifold and build a custom piece, weld it in. But I mean, we're talking a lot of fab work there. Fortunately, this old header comes off. And so you can address all of that by going to an aftermarket style header. So even if you don't want to shell out for the vintage inline's cast aluminum head, there are still a lot of modifications, and most of them on this build are applicable to here, that you can really increase the performance of your motor. I'm talking about the Yellow Terra rockers, the headers here. As I said, changing this from like a 1-barrel to a 2-barrel, or maybe going to an EFI system like the Holley Sniper system. So lots of things that you can do here, and I highly recommend that you take advantage of them. But without further ado, we're going to move off of this topic and we are going to keep on building this guy.
Now it's finally time to install the cylinder head. Now, if you're using a vintage inline's aluminum cylinder head, you must use ARP studs to install the head. You cannot use the original hardware. So start by taking your studs and giving them a liberal coating of ARP Ultra Torque Lube. Then hand thread them into the block and repeat this for all the other studs. Before installing the head, we did a quick measurement using a dial gauge between the block deck and the pistons. We then installed the head gasket, but unfortunately I forgot to turn the camera on and I lost the footage of installing the head gasket. So yeah, I guess you can stare at this head gasket a few extra seconds. Then we went to go install the head. Now to install the head, lift it up with another person and carefully and evenly lower it over the block studs. Then immediately notice that something looks weird like we did, and realize that you installed the studs backwards and that you've got the long ones on the wrong side. Take the head off, redo all the studs, and start over again. With the studs actually in the right place this time, it's time to actually install the head. After using ARP's Ultra Torque Lube on the threads of the studs, simply torque down the hardware until it's loosely tight. you'll want to use a torque wrench to get it to final torque. Again, using that method of 2/3, 3/4, and then 100% final torque. It's important when installing the cylinder head that you go in a spiral motion as you torque these down. This ensures that you get a good, evenly distributed load across the head. Next, it was time to install the roller rockers, but before we show you how to do that, Past Me is actually going to talk about one of our sponsors for this build that provided our roller rockers. Take it away, Past Me!
Thanks, Other Me. One of the other sponsors of today's video is Yellowterra. Yellowterra is an Australian-based company that specializes in performance components for different motors. Specifically, we are using their 1.65 ratio roller rocker kit for the Ford 200. Now, what makes this kit so special is that it is the only kit on the market that we're aware of that is literally a bolt-on upgrade for your Ford 200. All of the other components out there that you want to use for roller rockers will have to be custom built up. This one comes with everything you need to literally bolt it onto the car. It comes with the roller rocker spacers. It comes with the grade 8 hardware to bolt it on. It comes with all the washers, the lubricant that you need. It comes with the instructions. Literally a bolt-on performance upgrade. Now, there are two things that it doesn't come with that you'll want to keep in mind when purchasing a set of Yellowterra roller rockers. One of those is going to be the Claysmith Cams hydraulic lifters. They are a self-oiling lifter. So because of their design, these actually block the oiling channel in the head for the Ford 200. The original head and valve train had the oil come up into the valve train housing. It then went through the midbar and lubricated the rockers accordingly. Because of their base design, these cover that channel, which means that you need an oiling push rod in order to get oil up into the valve train assembly and keep it lubricated. So the other half of the equation and the other piece of hardware that you're going to need besides the self-oiling lifter is the hollow ball and ball push rod. The hollow ball and ball push rod will allow the oil to travel up, come out through here, and lubricate the valve train. But those are relatively inexpensive and they're readily available from our other sponsor, Claysmith Cams. So anyway, upgrades compared to, let's say, the OEM valve train. One, you have a roller rocker. Roller rockers, apart from having, less friction and wearing out slower than the OEM style roller rocker, are going to provide less parasitic friction because they are rolling. They're not sliding and pushing on it. Another great aspect of them that is a big upgrade is their ratio. For those of you who are not familiar, the ratio when you refer to roller rockers is how far from one side across the pivot point that your range of motion is amplified. For example, 1.5 ratio roller rockers would go this far. Let's say a 1.7 ratio would go this far. So a higher ratio means you have a higher amount of movement on the sequential end of the roller rocker. Now what that ultimately means is that your valves are going to get pushed in farther, allowing more airflow into the engine and higher performance. So ultimately, it's an increase in performance. And one of the things that we all know the Ford 200 suffered from was inadequate airflow. All in all, this is a great upgrade. And again, I highly, highly recommend that you guys purchase a set of Yellowterra 1.65 ratio roller rockers. You can find these available here in the US through Vintage Inlines. Contact Matt Cox, the owner, and he will be able to get you a set of these. So again, a very big thank you to our sponsor, Yellowterra. Thank you guys so much for providing this 1.65 ratio roller rocker set to us. I cannot wait to see what the performance gains on this engine are going to be, in no small part thanks to these roller rockers. So now I'm going to turn it over to Alternate Dimension Me, who is going to talk about one of the other sponsors for this video. Alternate Dimension Me, take it away. Excuse me. Thank you, other me. Now, our other sponsor for today is Holley. Now, we're going to be talking about some of the other Holley products in another episode as a sponsor for that episode, specifically the EFI portion of this build.
However, today we're going to be focusing on this, the Holley Hyperspark distributor for the 4200 straight 6. Now, Holley was kind enough to send us one of these. This is a great upgrade over the OEM distributor for a couple of reasons. One, no point style contacts. So you're no longer relying upon the physical breaking of points inside that distributor to make sure that your spark gets, or your signal gets interrupted back at your coil, which then creates, you know the deal. You saw the video of where I shocked myself. Aha! Aha! Anyway, this is now all digitally driven, and it's a plug and play ready to go with a brand new coil. This is going to do great. We're actually going to end up replacing this cap with just a billet cap because we're going to be going to a coil near plug in the future. However, for those of you who don't want to go to a full EFI build setup, it comes ready to go with your spark plug wires, and it's a plug and play pretty much. And it's just absolutely fantastic. You're going to get much greater reliability. You're going to get much greater spark out of this. So huge thank you again to Holley for sponsoring us on this video, and we look forward to talking about their other products for part 2 of the motor build when we go from the carbureted setup that we're going to be using for breaking in this motor to the full EFI, which is the full performance build. I've got some evil deeds that I have to get back to, but in the meantime, I'm going to kick it over to Glasses Me. So Glasses Me, you're up.
Now before you actually install the rockers onto the head, you're going to want to make sure that you drop the push rods into place. Now an important note about these push rods, if you're going to use the Yellow Terra rockers, is that you need to use a ball and ball hollow oiling push rod. This is because the adapter plate that's installed in the head, as you can see here, actually blocks the oiling passage that's normally used to oil the stock rockers. Once you have your push rods in place and you have your adapter plate bolted to the head, place the rocker spacers onto the adapter plate, and then in pairs, put the roller rockers onto the spacers with the bolts running through them. You might find it easiest to install the roller rockers in the firing order or to rotate the crank as you're installing them, just to ensure that the rods kind of play nice. Next, loosely torque down the bolts that hold on the roller rockers, and then using a torque wrench, final torque them down. Rotate the crank to ensure that the rods, lifters, and the rockers are all working together. Once we had installed the roller rockers, it was time to set the lash. Now because these are roller rockers, you're going to want to set these to 0 lash. Now we did the first couple in pairs by rotating the crank and using the modified lifter position to identify when the roller rocker was ready to be adjusted, but we found it was actually easier to do these one at a time across the entire cylinder head so that we didn't installed on the cylinder head. Now the larger ratio compared to stock means we're going to get more airflow through this cylinder head, and again, giant air pump, more airflow is better. After that, it was time to install the main crank bolt. After installing the main crank pulley, we used a red thread locker or permanent thread locker to install the main crank bolt. Make sure that you use a permanent thread locker. You do not want that main crank bolt backing out over time. Next in the installation process, it's time for the water pump. Now I started by applying some of that aircraft sealer to the gasket for the water pump. Once I had it fully coated, I then applied the gasket to the engine block. Now at this point I decided to apply some of that aircraft sealer to the water pulley itself, and in reality I made a mistake here. What I should have done is applied more sealant to the gasket itself rather than to the water pump itself. If you have a not so steady hand, you can accidentally get some of that sealant in the high flow water pump that we have here, and that can come up the works. So next time, if you're building this up, don't apply it to the water pump like I did. Apply it directly to the gasket on the block. Once I had cleaned up any errant aircraft sealant, I then installed it onto the block, again using these ARP stainless steel grade 8 bolts that we got. Next, it was time to install the valve covers. Now, after a couple of minutes of mindlessly standing around looking at the valve cover gasket, I eventually got around to putting it on. Now when you're installing the valve cover gasket, you'll only want to apply aircraft sealant to the valve cover side of the gasket. This is to ensure that when you take the valve cover off, the gasket goes with the valve cover and seats correctly every time. Because the valve cover is one of those items that you may or may not take off more frequently than other components, having aircraft sealant on both sides of the gasket can cause it to be damaged if you're taking it on and off too often. So it's best just to put it on the one side, and that's the valve cover side. Once you've got the valve cover gasket seated, simply bolt it in place. We're again using those ARP grade 8 stainless steel bolts. Now it's time to install the headers. Now we have dual 3-to-1 stainless steel exhaust headers that use studs. Now when you're installing the studs into the head, it's a good idea to use at a minimum ultra torque lube. It's also recommended that you might consider moving up to something like an anti-seize, particularly if you're going to be using non-stainless hardware. The anti-seize will prevent any corrosive actions happening between the steel hardware and the aluminum head. Once you have all of the studs in place, put the header gasket over the studs. Now place the headers over the studs themselves, and using a couple of fasteners, finger tight them into place so that it doesn't fall over. Then finger tighten the rest of the hardware in place until you're ready to final torque. To final torque the headers, you're going to need to use a combination of a standard torque wrench and an extension on the torque wrench in order to access some of the fasteners. Next, it was time to install the intake manifold. Before you can install the intake manifold though, you'll want to ensure that your gaskets for the intake manifold match the diameter of the inlet ports. To do this, gently bolt them in place at the inlet ports, place rags inside the ports to catch any falling debris, and then, using a razor, very carefully remove any excess gasket material until the diameter of the gasket matches the diameter of the port. This will ensure that you have smooth, even airflow going into the motor. Next, place your intake manifold over the gaskets, aligning the holes for the bolts. After you've applied some anti-seize to the bolts, thread them in from the backside and then begin to torque them down. Now, because there's very little access in this intake manifold to access the nuts, it's pretty much impossible to be able to get a torque wrench in there. So you'll need to use the quarter to half turn pass snug and to call it good enough. Now at this point, we took the opportunity to install the fuel injectors for the sequential port fuel injection as well as the fuel rail. For those of you not running a full EFI conversion on your motor, you can actually skip this step as you'll be using a standard carburetor. Now these particular injectors are from Holley and we're using a dielectric grease on the seals to help them install. Last but not least, it's time to install the carburetor adapter and gasket as well as the carburetor itself. Now, we're actually using a throttle body because we're doing a full EFI conversion, but this is the point in the process where you would install your carburetor. With the throttle body finally installed, it's time to take a look at the final product.
So that pretty much wraps up this week's episode on the Engine Gremlin channel on how to build the ultimate Ford Straight 6. I had an absolute blast filming this and building this motor. I hope you guys learned something you can take back to your own garage and apply to your own motor. We're going to be back in a couple of weeks detailing how to do a full EFI conversion on these motors, and then we're going to be back again with another episode where we come back here to DC Racing Engines and throw it on the dyno to pull the horsepower and torque numbers and to tune it for best performance. Speaking of DC Racing Engines, I really want to give a huge thank you to Rick and Tim of DC Racing Engines. Those guys have been absolutely fantastic to work with. They've been very accommodating of our schedule and letting us come in here and film. I have learned a ton from Rick on motor building, things that I did not know. I mean, and just look at the end result. I mean, this thing is just beyond gorgeous. This is a sick little piece, as Rick puts it. So thank you guys so much. And if you're in the Denver area and you need a performance motor build, don't hesitate to reach out to DC Racing Engines. Link is going to be down in the description for DCRacingEngines.com. You know, whether it be a motor that you need for racing, such as drag strip, street racing, track racing, oval track, or maybe you just want to do a rebuild or a performance rebuild of a motor that you use in your daily driver, like the build that we have done here. They are extremely good at what they do. Very wonderful to work with, and they are going to give you the best possible motor that you could hope for. So again, don't hesitate to reach out to those guys, and thank you guys so much for working with us on this build. It has been an absolute blast to date. Speaking of people that I would like to give a thank you to, I want a huge thank you to our sponsors to date: Clay Smith Cams, Vintage Inlines, Holly, and Yellow Terra. You guys have been absolutely wonderful to work with, and your support culminating in this build has just been immeasurably awesome. So again, a huge thank you to our sponsors. Links to all of our sponsors and all of the parts in this build are going to be down in the description. So if you want to replicate this build or do something very, very similar, you can do that. Otherwise, I think we're pretty much done for this week. Like I said, we're going to be back in a couple of weeks for the EFI conversion video and the dyno video, and in between there, we're going to be having a couple other videos detailing the suspension portions and how to replace pans on the Mustang. So feel free to stick around and watch those. And if you don't want to miss those, make sure you like and subscribe. But until then, I will see you guys next time.